Another topic that's on your exam from chapter 1 has to do with finding distance between points, and the distance formula, and I'm using the chapter 1 test, problem number 8. And if you don't have the chapter 1 test, problem number 8, in front of you, you can just work this out as practice, because it's going to be, this is a big item. I need to reassess it. It didn't go well. A is sitting here. B is sitting, is this even distance formula? No. This is not even distance formula.
Delete.
Nope. Yep, this one's not even distance formula. Okay. Relevant to chapter 1, finding lengths. And I'm asking you guys, well, what is the distance formula that helps us find lengths? Put it away, please. What is the distance formula that helps us find lengths? And I hear some of you guys like, you got the idea of what it is? I'm sorry. So distance formula comes when we take, I think we wrote it as x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. And I know when I've been talking about this in the past, I know I said this, set it up naked. Set it up so you can have the places to put the points. When I say set it up naked, some of you guys looking at me like, yeah, but you remember. So what I mean is, I'm going to put the x's and their difference here. I'm going to put the y's and their difference here. This is probably sounding and looking a little more familiar now. So then, let me go back and let's just say these are the x1s, y1s. This is x2, y2. And then this stuff doesn't happen quickly in your calculator either. You really want to go through the process. So this is going to be negative 1 minus 2. This is going to be negative 1 minus 4. And then I'm going to go through and I'm going to do this in baby steps, because honestly, putting this all in the calculator at once, and I'm like the expert of all this, there's never been a time that I haven't screwed something up trying to put it all in the calculator at once. So your calculator is only as good as you are in terms of organizing your work. Negative 3 to the second power is going to be positive 9. And without parentheses in your calculator, it would tell you that it was negative 9. That's not right. A negative times a negative is positive. And negative 5 to the second power would be 25. So the answer to this would be the square root of 34. And I would be all right with you putting the square root of 34, but you guys have a calculator. Could somebody tell me what that is? It's probably 5.8, 5.9-ish. Go into your calculator and do that. You guys got somebody. I don't have one sitting here. So we use the distance formula to find the length of a segment, and then we go through 5.8. That's what I estimated it to be. And then we go through the process of just simplifying, plugging in our x's and y's, and simplifying as we go down. So chapter 2 review, relevant to our geometry exam. Just looking at the diagram and answering true or false. Just a couple of reminders. You know, our names of the planes, there's no points next to them, so those have got to be how the planes are named. Do planes L and K intersect at line PS? Make sure you show 2 arrows here. It's kind of hard to see, but that's what they're utilizing there, is line PS. And I would say that that is true. That's the place where it almost looks like a card that's folding. So planes L and K are intersecting at that line PS. Go ahead. Yeah. Number 11 is asking, do points U, M, and O sit in the same plane? Do points U, M, and O sit in the same plane? O is in both, actually. But I would say that this is true. They all 3 sit in plane L. O is in both, but do they all sit in the same plane? That's what coplanar means. And then we're looking at QOP. Is QOP a right angle? I'm going to say yes, because I see that right angle marking there, showing that those 2 lines are perpendicular. Go ahead.
Since we see the right angle there, it's okay to assume that P, O, and M is right angle, right?
Yes. MQ And this is line MQ that they're talking about. Line MQ is in plane L. I'm going to say no on that one because what I see going on here, and this is, it's tricky, but it's almost as if, well, it's not almost as if, it is as if. So if I were to take, here we go. Here is my plane. So here's my plane L. Here's my plane K. The way I see it is that this line MQ is like, it's sitting in plane K and it goes through this way. And so I see it laying in plane K, but it only hits plane L at point O. So that's my justification here, is that it doesn't, the whole line doesn't lie in the plane. Point M is in plane L, but the whole line MQ is not. Sure. Sorry. Okay. Next, 14, line PS. Line PS and MQ intersect at PS and MQ intersect at O. Sure do. Yep. True or yes, however you want to answer those. So again, a lot more notation and, you know, diagrams and making sure you're talking about things correctly here. Moving on to solving our equations, the idea that you have to justify each step. This takes us to the group of problems that allow us to undo things. I think that most everyone is reasonably confident with the idea of undoing. 3x plus 4 equals 31. I undo plus 4 by subtracting 4. I'm going to finish this problem up by dividing both sides by 3 to find out that x is equal to 9. There's my solution. Your justification has to do with you telling me that undoing and getting from this line to this line came from the subtraction property. And then undoing from this line to this line came from the division property. We can add, subtract, multiply, or divide anything we want in an equation as long as we do it to both sides. And then the properties are named just like that. Did I just add to undo? It's the addition property. Do I multiply to undo? It's the multiplication property. Go ahead.
I wrote it different. It's the way I wrote it. Okay.
Sure. Now I want to go on to 2. The first thing that I have to do is distribute. I'll go back in a minute and I'll write down my steps, but let me just do the math. I'll write down my justifications. 6x plus 3 equals 15. Then I'm going to take 3 away from both sides. And again, I'll come back in a minute and write down my justification. 6x equals 12. I'll divide both sides by 6. X is equal to 2. 3 steps of justification on this. To get from here to here, I use the distributive property. To get from here to here, I use the subtraction property. To get from here to here, I use the division property.
So on the test, if we got to do this, can we abbreviate?
Yeah. Number 3, I've got distributive going on both sides in number 3 as I get this problem going. Half of 16x is 8x. Half of 8 is 4. 2 times x is 2x. 2 times 16 is 32. Now I'm looking at undoing. There's different ways you could start this, but my best choice, I like to take away and deal with the variables first. Taking 2 x's away from both sides. Now if you started solving differently, maybe just sit back and watch to make sure you get the same answer. I decided to take 2 x's away first. Then I'm going to add 4 to both sides. 6x equals 36. Then I'm going to divide by 6. And x is 6. Now again, you could have solved this in different ways. Just make sure that your steps and your naming of your properties matches the work you did. Everyone's first step should have been distributive property. My second step was subtraction property. My third step was addition property. My fourth step was division property. So going through and doing it and then going back and writing down how you're undoing is probably your best method. I started solving in my packet. I already started solving this problem here. A few more steps. The first thing I did was distribute and got 3x minus 12, and then I brought down my plus 3 and I rewrote my x minus 2. From there, I combined like terms. Negative 12 plus 3 is giving me negative 9. And now I'm in the position that I just want to start undoing. So I distributed, let me just justify those steps because they're here. Distributive property, and then from here to here, all I did was combine like terms. My like terms were the negative 12 and the 3 that I put together on the left that I needed to simplify that side before I could start undoing. Now I'm going to take x's away from both sides. You can start this problem differently, but that's the way I chose. Say it again. Sorry about that. Then I'm going to add 9 to both sides. So 2x equals 7. Then I'm going to divide everything by 2. And x is 3.5. I've still got a few other, you could write it as 3.5. Let's see, I used subtraction property. Then I used addition property. Then I used division property. So thinking through all the steps that you're taking. Number 2, lots going on in number 2. The very first thing that I did, and I'm going to move this over, here we go. In number 2, I had circled, I'd started this problem with somebody the other day. The very first thing I did, there's brackets and parentheses. I looked inside these brackets and realized that the only thing that I had to concern myself with on this right-hand side was putting together the like terms x and 2x. So these squared off brackets became, I put them as parentheses right here because I just put together x and 2x. These parentheses outside the quantity 2x minus 1, there's nothing to distribute in there, so I could just gather up the like terms. So my first step would be combine like terms. On the right-hand side, all I did was put together things that were like to write that simpler. And then my next step would be to do my distributing. So I'm over here on the left-hand side, and I keep my, oh, I distributed over here too. Shoot. Combine like terms and distribute. I did both of those things. That's how I got negative 1x minus 5. So now I'm going to have to distribute again on the right, 9x minus 3. And then I start my undoing process. I'm going to add 1x to both sides. Careful with this 5. It is negative as you come down. 10x minus 3. I'm going to add 3 to both sides. Negative 2 equals 10x. I'm going to divide everything by 10. So x is equal to, it's negative 0.2 if you put it in your calculator. Going back, I distributed again. This came up as a question last week. Can you write down the same property more than once? Absolutely. Sometimes you have to undo by adding more than once. It happens right here. To get from here to here, I use the addition property. But then to get from here to here, I use the addition property all over again. In my process of undoing, I might be repeating those properties. And then last but not least, I did the division property.